All right. Hi, everybody. Um, Good morning, good afternoon, or good evening from wherever you are joining from. Um, I'm Subomi, and I'm happy to be here. I'm happy to be here. They mentioned the organizers mentioned that this is targeted to be sort of like QCon, and so I think it's a goal for me to speak at QCon. So maybe this is a stepping stone. Um, but I'm happy to be here. I'm excited to have this talk and also have Convoy sponsor the conference. Um, this talk is on building backward compatible REST APIs with rolling versions. Um, a little bit about me. I'm a software engineer, also the co-founder and CEO at Convoy. Convoy is an open source webbook service that enables you send and receive webhooks at scale with retries, secure breaking, all that juicy stuff in one binary. Um, and in this talk, this is sort of like the eye level agenda. I'm going to give a bit of background, how we sort of got into this space, how we sort of got into the problem space, what we're thinking about, the constraints, sort of talk a little bit about that. Then sort of go into what rolling versions are, explain the concept, and then explain the Golang implementation. So on a high level, if you check the description of the talk, is the concept of rolling versions was something that piqued our interests and what we were trying to solve. Also, there wasn't sort of like a Golang implementation of the library, and we were able to port some of it. There's still some things to port, but some of it was we're able to port it. And exactly the talk will be showing, explaining the concept on one hand, and also explaining the Golang implementation. And I hope that like other people can port it into other libraries, so we have more backward compatible REST APIs. Because I really, really like the topic essentially. I think that's something that should be more widespread. So when I stumbled on the topic myself, I'm like, I think this thing should be more widespread. I don't know. So yes, let's dive into it. Um, so I'm sure all of us build REST APIs. Um, Many of us have built REST APIs, and many of us have sort of maybe built REST APIs for front-end developers to consume. Many of us have built public REST APIs of like Paystack that we are familiar with, or like public REST APIs that other businesses can consume. So many of us are familiar with the concept of REST APIs. And also many of us are familiar with like versioning the REST API, like API v1, API v2, API v3, semantic versioning for your APIs. Um, and so why we sort of got into this space was when we started to release Convoy 0.1, Convoy 0.2, Convoy 0.3. Like Convoy is not at version 1 yet. We're still in the 0.1, like before getting to the 1.0. And we wanted a way to continuously improve the API without breaking old integrations. We wanted like a constant feedback loop where we can release a new binary to our users and they can test it out without essentially changing the code they wrote for the previous version, right? And this can be as simple as configuring time duration, right? Like, do you want to configure time duration with an integer? Do you want to configure time duration? If you want to configure it in seconds, you say something like, okay, this field is only available in seconds, so send me integers. Or in Go, you have this nice utility where you can do something like 3S, 3D, 4D, 4M, stuff like that, that translates to 3 days, 4 minutes, stuff like that. So we wanted the freedom to continue to improve the API to be very intuitive and not be stuck into something we shipped in 0.3 and we can't change it because users are already written code against that API. That's sort of like the first and like the real pain. And yes, common wisdom around like API versioning is you do semantic versioning. So you have API v1, API v2, and then API v3 as you continue to ship the API and grow your business or your product or your project. Not everything might be a business. And so the problem we had with semantic versioning idea was it sort of incentivizes you to create big bang changes. Like you sort of have to make a judgment of, is this change enough, or do I have enough changes to design a V2, right? And then you sort of have to wait for the changes to pile up or for the need to increase, and then you create a version 2 for your API essentially. And then you can quickly run into a problem where you sort of split your user base, where you have users on one version and you have users on the other version, like version 1, version 2. And obviously from there, you go into other problems where you have new capabilities in version 2 that are not available in version 1. You have to sort of force users, you have to sort of like make a business decision to deprecate version 1, push users to version 2. All that's like trade-off, all that business decision you have to make. But in our scenario, we just wanted to improve the API. We wanted an intuitive API that when you come across the project and you wanted to sort of send out webhooks, it should be intuitive, and we shouldn't be stuck with what we shipped in previous versions because users are already depending on it. That was sort of like the thesis. And so lastly, yeah, we believe that infrastructure should be boring. Like there's this nice article I read from the founder of Dragonfly DB that talked about this concept in detail. The link is in the slide. I'll show you very soon. But we believe that infrastructure should be boring at the end of the day. We do not want to ship Convoy 0.7 and sort of have users that integrated when we release 0.5 to have to go back and change their code to sort of fit the new API. So that was sort of like the contention, and then turns out that what we were thinking wasn't new, wasn't novel. This is how Stripe has built their API for years, such that if you integrated Stripe, sorry, in 2015, your integration will still work fine, even in 2023, without you writing new code. And they kept improving the API, and they kept creating something more intuitive to the user. So Stripe does this, Intercom does this, and so it was easier to sort of like to build or to reason about, because they all sort of like had done they had sort of like conceptualized the technique and written about it. And even I found Keygen also does this, and Keygen wrote a public library that enables you to do this in Rails. Unfortunately, I'm a Rails programmer, so I was able to like look at it and say, okay, I need this for Go, and sort of take it over into Go. And that's why we are here today. So let's dive into what rolling versions are. So rolling versions, in comparison to semantic version, I define it here as an API versioning technique that ensures backward compatibility by applying request and response transformation to each user request using change objects. That's sort of like a lot in that definition, but essentially what's happening is for every user request that comes into the API, we are able to do some magic to ensure that the day you integrated the API, you would never need to change that integration except you willingly decide to. But let's look at an image that sort of drives home the point, or sort of helps us take this, I think, dense definition to something that is easy to understand, if that makes sense. Um, so if you look at this diagram, what's happening here is, again, credits to Kijen. This image sort of drove the point, or sort of helped me really understand rolling versions, um, and sort of was key to actually understanding the concept and building building the Golang implementation. Um, so what you have here is 4 versions. You have a version 1.0, a version 1.1, a version 1.2, a version 1.3, a version 1.4. Now, when a user request comes in, every user request sort of explicitly or implicitly has a version, right? So explicitly means that the user specifically says, I know the version I am on. I am on version 1.2. So fulfill my request with version 1.2. Implicitly means if the day the user integrates, you sort of lock the user at a particular version. You sort of say, you integrated at this point, and we're going to lock you at this point if you decide not to send the request header every time you send your request. So what's happening here is the concept of change object is the change object holds maintains the contract between one version and the subsequent version. Let me put it that way. You can think of it as, because APIs are contracts, right? Like it's a contract between the client and the server, right? So every time I send a request, I send you X, you're going to send me Y. And you're going to send me in this shape and format, and you're not going to ever change that because we've agreed on this contract. Now, the change object is saying that if I change my API or I release a new version, going from version 1.0 to version 1.1, there is a change object in between. And the change object can take a request that was designed for the 1.0 API and sort of apply transformations on that guy to fit it for the version 1.1. And so you can, and then when that happens, it can sort of continue bubbling until the end where you have the code base, like in this example, version 1.4, which is the most recent version. And version 1.4 contains like your handlers, your controllers, your service object, all that stuff, and sort of generates a response that's compatible for version 1.4, and then it bubbles through the change object again until you have something compatible to a version 1.0 API. You can sort of think of it like a stack computer, or if that makes sense, like it bubbles through the stack and pops back out, right? That's the simple idea. It takes the request, puts the payload and the headers, and transforms them through and transforms them back. Now, so I sort of modified this image to sort of also portray make the example more relatable. So if you look at this second diagram, what you are seeing is an version 1.1 request that comes through the API, and the red mark on the version 1.0 shows that we are not going to run the change object on 1.0 because this user integrated on 1.1. So it's going to run 3 transformations here: 1.1 to 1.2, 1.2 to 1.3, 1.3 to 1.4, 1.4 back to 1.3 to 1.2 to 1.1, and then 1.1 response goes out. Just sort of like the high level description of what rolling versions are. It sort of has several like benefits, like your core code base is just one code base, and you expose just one API, which is the most recent API. And then you have this layer of transformations that just go in and out depending on how far away the user is if that makes sense. I hope this is clear, but let's see a quick example, sort of drive home the point. So in this example, we have an API that retrieves a list of user objects. The first one on the top right, what you are seeing is the first, the initial version here, and I wrote the initial version to mean that in a world where you had no rolling versions, right? You didn't plan to do transformations. This was the API before enlightenment. And so you have full name and profile. The profile is the user ID to retrieve the user profile and get more details about the user. Full name is first name and last name of the user. And now the next version is users are saying, we do not want full name, we want first name and last name. We do not want to have to string and split, and figure out what the first name is or what the last name is and sort of maybe confuse our users. Can you sort of give us first name and last name as two separate fields? And like, sure, we can do that. And then we release a new API that has first name and last name. Already we break the whole users that rely on the full name field straight out of the box, right? But you can obviously see how, or you probably can see how you want to make the API more intuitive. Like you have the opportunity to make the API more intuitive, but for the sake of all the integrations, we'll let peace reign, uh, quote unquote. But then we have a third version where the users say, I do not want to make two requests to retrieve the user object and retrieve the profile object. Can I make one request where you expand the profile object to me? Um, Obviously, there are other ways you can do this, like by ship a new field, expand the payload, name it profile object. But for a new user that's coming to you for the very first time, they're going to have to learn an API that's probably not as intuitive, but you're carrying over burdens of previous integrations that is just a pain to maintain. Like you've done it, you have profile as a UID. So you can ship profile object as a new field, but new users will come and you're just carrying over burden because you cannot make a change. Whereas in the new API, and the new users that are coming to you to integrate your project, your business, whatever it is, have the opportunity to integrate an API that is excellent, that is intuitive. And so you have these three versions of the API. You have the first one, which I showed. Let me go back. Full name and profile. You have the second one, which is first name, last name, and profile. And you have the third one, which is first name, last name, and profile object. I'll show a quick demo on my system of how this works. And then I'll come back and show and sort of explain the internals of how this is represented. Let me see if I can switch what is presented. IMD. All right. Okay, so I have this guy running on my laptop. A simple API in Go that has the list user handler, and I have wrapped this in like the version API. This is the request migration library that sort of wraps the list user to enable me apart from this transformation. So what I would do is I'll run this guy here, and I'm going to call the API. Now, notice that I'm calling the same API localhost 9,000 users. And if you check the headers, I have no versioning, right? Like this was the world without versioning. Like it was the world where there was no rolling versions. I just did like maybe API version 1, hoping that I'll do semantic versioning, but I ended up switching to rolling versions, which was the case in Convoy. But I didn't do this. I'm going to take this out here. And then when you call this, you sort of see your full name and your profile, UID, all the stuff here. All my users' full name and email. And then when you come down to the new version that you shipped, if you check the headers here, you have X example version 2023-0401, which is just, April. But this is hypothetical. You call this guy, you have first name, last name. Now, the same API, the same endpoint, different experiences, different results. And then you can sort of the new guys, that which is like the most recent API, specify 23.05.01, call the same endpoint, same API, and you have something different, which is profile, UID, GitHub URL, and Twitter URL. Three different users are experiencing the API in three different ways. And the first and the second users have their needs met and do not need to change anything to make the API work for them. They can, in the future, decide, okay, it's time to upgrade to the most recent version for reasons best known to my business. But the API is not essentially forcing them to do that, right? Compared to, say, you have like a V1 and a V2 where potentially you have capabilities in the V2 that might never be in V1 just because of how the API is designed. And so rolling versions sort of enable you just have this thin layer of transformations that ensure that you have one API that's intuitive and everybody can sort of not have to break the wall to integrate the API, if that makes sense. So we can go back to the slides. Can I do it myself? Okay. So the Golang implementation, on a high level, we sort of have seen the output. Like I showed the demo first, sort of see the output of what we are trying to achieve. And now I can show you how it works under the hood. And hopefully you can sort of write similar implementations in your favorite language, Java, just your favorite language, Node, anything, if that makes sense. So let's dive into it. The first thing in the implementation is you want to have like a map of versions to transformations. So we have this type called migrations. You can think of it as the way you think of database migrations. So in your normal database migrations, like maybe in Rails and Django, I'm not so familiar with Node, but I'm sure like you have similar concepts. You have one migration file that sort of holds several transformations, like add a table, drop a table, add an index, remove an index, several things in one migration file. Similar thing here. So you have one version with several transformations, and it's possible that in one release of one version update, you have multiple transformations that affect different resources. In the example I showed, I was only transforming the user object. But you can think of scenarios where you have like multiple objects in your API, and you can be transforming multiple objects. And so each version, so you have like 2023, 0228 in this example, maps to two migrations, right? So you can have n migrations as more transformations you are doing in that particular release. So you have a map that maps a string to an array of migrations. And then this is sort of how it maps to the example I just showed, right? So in the example I just showed, we had a version called 2023.04.01, like date versioning scheme, which maps to combine names for user migration, which was where we sort of said the new API does first name and last name, but these old guys want you to combine it and show them full name. They do not want to see first name or last name. And then in the next version, we did expand profile for user migration. In the old guys, they want to just see profile UUID essentially. So you have the list of migrations that you register to the library. And then the core of the migration is the migration interface, right? Like every transformation in a version sort of has four methods to define, two predicate functions and two transformation functions. Should migrate request is asking, should we migrate this request based on what you are seeing in the request? So you sort of write your if else logic in that method. should we migrate the request or not? Migrate request does the actual job of migrating the request. And then we're passing in pointers in this method. So you can mutate the request object and the response object. The problem with this already, if you can see, is we in Go, once you read the body of a request, or once you read the body or you read the body of a response, you can't read it again, right? It's already empty. So this interface sort of, I want to change it, but the problem here is you have to always reset the body after you read it. You have to always reset the body to ensure that the next transformation in the chain can read it and continue transformation. The other problem here is if for someone looking at it already, and like you already, the number of transformations that happen already sort of multiply the amount of reading and marshal and unmarshal that you have to do on all your payload, and that sort of can increase latencies on your API, definitely. I think there are some optimizations you can do to the library to also help fix that. But this is the core of the library for each transformation. Yeah. So you have this guy, combine names for user migration, implementing the interface, all these guys implementing the interface. And then you set it up in your library. You configure the library. You have the version header, the current version, and the version format. The version header is simply what request header should we check to get the header. And in this example on the left, we retrieve the version from the request header. In the example on the right, you can sort of retrieve the version from your database, right? Say you have something like Stripe as well. If you integrate Stripe, the day you sign up, you are locked on the dashboard to the most recent API version. So if you decide to call the API with a specific version, you can sort of go around the version that was locked to your account already. But if you do not specify a request header, then the version that was already locked to your account is used, and that's what you can achieve with the example on the right. And then to use the library, you can either wrap specific handlers, which I think is a better way to start out versus wrapping the entire API, which is the example on the right. So you wrap the entire API as a middleware, or you wrap specific handlers that you want to start applying transformations, just sort of see the benefits, if that makes sense. So that's sort of like the high level of, that's sort of like the entire library, essentially, from defining your transformations, registering your transformations, defining how to retrieve user versions, and setting it up on your handlers. What other utilities are available? We sort of thought, again, when you think about how many transformations you are doing, it's possible that you start to add some weird latencies to your API that shouldn't exist. Again, like it's a game of trade-offs, right? Are you trying to provide excellent developer experience, or you are going to maintain all this code because you do not want to break the users? It's sort of like a game of like trade-offs, right? But we added this to the library so that you can easily check and know when something is going off, right? So this is like an histogram that shows you the versions from, and so sort of has these labels that enables you check the version, the user's versions, like from and so, and enables you see, and from there you can sort of do like your check the percentiles and know did we write some weird transformations that's causing this um, latencies to spike to a weird number and sort of help, like, in the event that you are helping the users with a great experience, you also don't want the APIs to become unnecessarily slow, if that makes sense. And so yes, you can get dashboards like this and sort of build alerts and know when something is really going off the hook, and solve it. And one nice utility about this as well is that when the dashboards go empty, you can sort of know when users are no longer using a particular version and deprecate it entirely, right? Like, it's as good as saying you can hold it available even for the last guy, if that makes sense. Like, you can sort of retain the version for the last man standing until you see like an empty dashboard where over the last 7 days or over the last, I don't know, 14 days, nobody has required that's gone through these layers of transformations, right? And then you can actually, with this data, or deprecates the oldest version, um, if that makes sense. Um, some in closing, some final thoughts. Right, the library was built with HTTP test response recorder, which wasn't essentially designed for regular production environments, sadly. But the problem is that, like, compared to like other language or environments, Rails doesn't give you a good way to handle response objects, because again, you need to take the request and transform it down the stack, and take the response object and transform it down the stack. Problem is that, like, if you try to wrap response writer, you might run into some very nasty problems, or you may run into some weird problems, because response writer implements some other interfaces that are not exactly clear to you, or yeah, are not exactly clear to you essentially. So you you have so you can run into the problem where response writer wrapping response writer might be tricky. But its response recorder was good to quickly test the prototype, the functionality, was backward compatible with handlers, works with early versions of Go, like versions before Go 1.20, 1.20. Um, but with HTTP response controller, which I'm going to use to replace response recorder very soon, it works in your regular production code. Might not be backward compatible, because if you do not use the other interfaces that response writer implements, then you are good. But if you use stuff like Flusher, Jackal, all this stuff, then you have to sort of make some changes to your handlers before you can use like the migration library. But the upside with it is it was designed for regular production code compared to response recorder. Um, some passing thoughts. Some changes to the API are much more complex than response transformations. So there's a good section in the Stripe blog that talks about how a technique to handle transformations of version changes that are not exactly response transformations. And there's a link into the article I'll share very soon. Also, handling arbitrary data migrations, e.g. webhook payload. So if you are going to transform, because like the webhook payload is also part of the API contract. So if you're going to transform your APIs, you might as well transform the webhooks. Not might as well, you should transform the webhooks payload as well. And so in the Rails library, if you check it out, there's also a link I'll share. They sort of give you this utility to enable what you do on the request response layer in just anywhere in your code base. Something I'm also going to implement in the Go. That's what I meant when I said I've not implemented everything. Other things you want to check notes is avoid N+1 queries and transformations, monitor for request latencies, and perform end-to-end tests to verify correctness. So in the bit of trying to not break your users, you're not, or in the bit of trying to give them a great experience, you're not breaking their integration. A couple of links that are useful to check out. And thank you very much.
All right, perfect. Thank you so much, Subomi. We have quite a number of questions. I know you can't see them, but I'll read them out for you. So someone said, this is interesting. So if I understand correctly, the API keeps moving and changing its responses, but every change requires a transformation to the previous version response. Then when a user calls the API, we can transform the current response down to the response the API version should require. That's kind of how.
Yes. It's also straightforward because all you need to think about when you are designing the change objects is you're only going from this version to the subsequent one. Like you're just going from A to B. You never go from A to C because you don't. It's weird to go from A to C. You go from C to B, and you go from B to A. Yeah.
All right. The next question is, for an API that allows users to specify versions in the request payload, is there any point using rolling versions? I guess like this, like for this one, you can either specify or not specify. If you don't specify, it uses the default, right? Or it uses the pinned one.
No. So can you read the question again?
So 1 second. For an API that allows users specify version in the request payload, is there any point of using rolling versions?
Also, so it's agnostic of where the version number is specified because again, the idea is that you have a contract with the user that send me this object or send me this request and expect X, right? So regardless of where the version number is specified, the idea is that there's an object that your API will return. And if you change it, you break the user. So if the user specifies the version, even in the request payload, you still need to respect the contract on that version, or you break the user essentially. So it's sort of agnostic to where the version is specified, either in the payload, in the header, in the DBs. It's agnostic to that.
All right. Thank you. The next question is the request object? Yeah. So I think we would take like 2 more, and then you can go to the, so in the main account, you can go to the stage and Q&A section, and you see the questions there, and you can just like reply them when you have some time. So let's just take one more. Is the request object that implements the migration interface in your Go implementation?
It's the request object
that implements the migration interface in your Go implementation.
Okay. I found this on the web first, the request.
Yeah, so I couldn't hear you. Sorry. Can you take it one more time?
Is the request interface that implements the migration, is the request object that implements the migration interface in your Go implementation?
I'm not sure what that means. I'm not sure what that means. The request object that implements the interface in your Go implementation. So what's in the implementation is an interface that defines a change object. So a change object simply receives a request, transforms the request or not, receives the response, transforms the response or not. So we do not sort of, that's the only core interface in the library. I'm not sure. Maybe you can rephrase the question and I can answer it.
I've asked the person to clarify. We need to end because another session is about to start. But in if you go to the main like event and you go to the Q&A section for the stages, you should see all the questions. And if you could answer them, that would be great. I think it would be very helpful for people.
Yeah, I will do that. This was helpful. This was great.
Yeah, this was really good. Thank you. We're very grateful. Convoy, thank you for coming up to speak. I think people learned a ton, and and I learned as well. So thank you. For everyone else, the next sessions are happening. If you go to the session tab, the next talk is an optimization saga in Go. And there is also another session titled How Butter.us handles recordings. So you can attend either one of those. They're both happening right now. So yeah, I'll see you in there. So go to the session on the left navigation bar, go to sessions, look for the sessions, and attend those. All right, see you. Bye.